Hello, Internet of Friends. Connecting large language model with private data is quite a trendy topic at the moment. Today we are going to build a chatbot to search and ask questions over the latest Tesla and Apple earnings reports. This video will demonstrate the power of connecting LLM with your own data and perform semantic analysis. Let's dive in. Let's start at high level. It's actually quite simple to understand. So what we're doing here, we are using the semantic and reasoning capability of a large language model. We will use that to connect to our own data. And finally, we'll perform a Q&A or search over your own data. What's important here is that your data are not used to train the large language model anymore. We are simply using the power of large language model to perform search over your private data, but there is a separation between the model and your data. Let's break it down using this simple diagram. But before that, we need to understand what is text embeddings. Now, embeddings are just numbers. So basically, we are turning the words that human understand into the numbers that machine understands. And if we put these numbers into a vector space, it kind of look like this. This is a vector space of 10,000 words with 200 dimensions. Now, what does that dimension mean? It's beyond me. I only know 2D and 3D. This is a 200 dimensions with 10,000 words. Now you can sort of see some words and some are close, some distant. Apparently, the closer they are in the vector space, the more similar the word meanings are. For example, this card and a card. Anyway, OpenAI has 1,536 dimensions. I guess more dimensions, more accurate the similarity search will be. Back to the diagram, we will start with the data ingestion phase. We'll load all the documents and then we'll split them to smaller chunks because you will have a lot of data and most model will have a token limit. After they are split to smaller chunks, we will turn them into the numbers, the embeddings, and store them in the vector database. And then when user supplies query, we turn those questions into embeddings too. So we can sort of compare numbers and numbers, right? After we compare the user's question against our database, we will select the relevant data to the question and then plus the user question, pass them onto the large language model. So the idea here is you don't want to pass all your data from database to the model. That will be very slow and very expensive. So we only pick the relevant data chunks based on similarity plus the question, and we'll send them to the GPT model. And then the GPT model will return the response. And that's how we do a semantic search based on OpenAI or most large language model. Now, what is Langchain? Langchain is a suite of tools that will help you to work with different large language model. And here you can see it supports multiple large language model. And then there are different tools it supports, like what we're going to use, for example, document loader. You can use the document loader to load different files during the data ingestion phase. We used the directory loader, which will scan the whole directory. There are text splitter you can use, or it supports, and we used one of the character text splitter, Tiki token. We can also use the vector store. So these are the vector database that it supports, the interface with. And finally, we have chains. Chains are just a chain of action, a combination of pre-built template of different commands. So remember, in your typical OpenAI prompt, you will have your questions and other properties to prompt to the model. Now with a chain, you just get a single line of code. Everything is pre-built, and Langchain will have different chain to do different things, such as chat over documents with chat history, which is the one we're going to use in this tutorial. There's summarization chain. There are simple Q&A chains. So it just really simplify and speed up the deployment if you just want to get something quickly going. And this chain also supports some properties you can fine tune. And you can see it's very easy to use during our code. Now let's dive into the code on Google Colab. First, we'll have the library installed as one of the requirements. So let me just quickly go through them. You have OpenAI, you have the Langchain. ChromeDB is the database, the vector store we're going to use to store the text embeddings. Tiki token is a library that OpenAI uses to account the tokens of the text. PyPDF is just a library to split and recognize the text in the PDF. Construct library is from the Langchain that's recommended to use. We can load the directory of files with different formats. And finally, we have the Gradio, which I've introduced on my previous video, that will quickly help us to spin up a web application for our large language model. From here, you're going to have some of the function to be imported. You have OpenAI, you have the Chroma, also text splitter, which is a Tiki token. And this is the chain we're going to use. It's called conversation retrieval chain. Finally, you will have your OpenAI keys here, and we can define the chain by calling different model. Here we used GPT-4. Now there's a bit of problem with the default environment that Google Colab has. You might get error when you're doing the directory load, scanning your files. You might get error of the Python image library. By default, you will have an 8.4 in the environment, and it won't work. And if you just go straight to upgrade it, it looks like it's going to give you 9.5, but actually it will also have problem. So the best way to do that, if you have a pure error, is to uninstall it first and then just run upgrade command, and now you will get a final version of 9.5, which works fine for us. So the phase one is the data ingestion. We'll always start with loading your documents. Now the Langchain document loaders is a tools package that aim to give you a convenient way of achieving all that. Now you can see Langchain document loaders support a lot of different type of documents. You can see the CSV loaders here. You can load your email, Facebook chat, Google Drive. You can have your PDF, Word, documents, PowerPoint, etc. The one we're going to use today is Directory Loader. The reason we're going to use Directory Loader is we want to make it as realistic as possible. So imagine you have a folder that has a lot of different files of all kinds of formats. And Directory Loader, what it does is it will load all the documents in a directory. Under the hood, it uses the Python's unstructured loader library, which if you look into that, there's a lot more dependencies need to be installed. From what I did, my test only required that. So if it doesn't work for you, for different file formats, have a look at this page. Now, to use the directory loader, each loader can only scan one type of document. So you're going to define the document, the file format right here, and you will create multiple loaders if you want to load multiple formats in the same code. So we switch back to our code. You can see here we have defined 3 loaders. One PDF, then the text and the Word document loaders. And we run this loop to load all these files once being scanned. And we printed out there are 5 files in our directory which I upload right here under the reports folder. I put a couple of formats. There's a PDF, documents, and text files into this. So let's run that again. And you can see it's loading up here. Next, after we ingest the data, we're gonna split them into smaller chunks and then store them as text embeddings into the vector store. Now, it sounds like a very complicated process, but with the help of Langchain, it just becomes a simple line of a couple of code. You can see we're using text splitter and turning them into 1,000 chunks. And then we'll call OpenAI embeddings, and eventually it's being saved to the database of our choice, Chroma here, the documents and embeddings. And that's it. If we run that, it will just turn all our data into embeddings and saved into the Chroma vector store. We are almost there. And next, we're going to define the chain we're going to use in this application. Now, what is chain? Langchain's chain are simply a pre-built set of commands that have been chained together. Why do we need to use a chain? Chain allows us to combine multiple components together to create a single coherent applications. And the chain we're going to use is called chat over documents with chat histories. Now, if you built the other bot with me in the past videos using ChatGPT, the GPT model, you know there are properties we're going to use. We're going to define our prompt in multiple lines. But now all that is gone and be replaced by a single line of code. This is the example actually I followed, and these are text splitter embeddings, same as the one we just went through. And here is just one simple line of code. You're going to call the chain and then start the conversation. From here, you can see we've initialized empty string called chat history to hold the conversation. Then the chain will call the GPT model by passing the user's question and the previous histories. Now, when the answer is returned, if we move down here, so this is the example of chat with no history. Here is an example of chat with some history. So what it did is, when you got these answers back, we're going to add this answer back to the conversation history. See this line here, which you didn't have here. Right, so we still start with an empty string, but we'll have this extra line here, basically meaning every time the user's question and answers from previous question will be passed back to the conversation history, and this always gonna be there. And when you pass the next new question with this conversational history to the model will have some kind of context. And if you have a look at the actual chain we use, click on the source, it will give you some idea what actually the command is doing under this chain. This will tell you exactly what is that chain doing behind a single line of code. And if you're interested, you can dive into this. Let's look back our code. We're going to define the chain. Notice I add extra property here. It says return source documents is equal to true. Now, if I debug the program within the Colab, I can see every time it returns a response, it actually cites the source document, but you won't be able to see in the web application we built using Gradio. Now, if you followed me on my previous videos, you can see how we can use Gradio to quickly spin up a web app to demonstrate our machine learning model. Today, we're going to do the same thing. We're going to use Gradio, and what we're going to do is we're going to select the chatbot functions, and you can take a look at the example code, and this is what's going to give to you, which you already seen in the beginning of the video. So pretty much I've just copied the example code and modified it with our input and output with the Langchain using ChatGPT. And you can ignore these random and time here, because what it does in this example is, because there's no actually model powering behind this. So when you chat within this example, it just randomly spins up some time and hearts and emojis. So you can ignore that. Coming back to our code, you can see we initialized the Gradio interface here, and we used the chatbot function. The main code here is what we described just now, but modified it to accommodate the Gradio interface. You can see the conversation variable called chat history started with empty string. Now we'll take the user's message, which is the question, and then will be a history. Now the reason I'm printing these, and you can see later on during debugging, is you can see actually the questions and history is being printed, and we'll print the history again called update chat history, which will be the answers from the previous question to be added to the history. So this variable will keep growing and keep getting added. And in the chain, we are passing the user's message and also the previous history together to provide some context to the model. And after that's being returned, we'll append it with the answer. So this chat history will always have the previous context. And then by setting the debug is true, we can see the results in our Google Colab. So let's run this and do some tests with the code. Here comes the demo time. As you can see, I have 5 files in my directory: state of union, did a Tesla earning report, Microsoft product list, a Google earnings transcript, and Apple's earning. So there are text, there's a PDF, there's also Docs Word document. Okay. So let's start with our first question. How much money did Apple make last quarter? Net income of Apple Inc. for 3 months ended blah 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 is that. And if we move down, you can see first we started chat history as empty string, and then updated chat history is what's returned after the model returned the answers, which means now this variable will have user's question and the model's response to that question. Now if we ask a second question, you can see these will be all kept in these conversation variables. Let's ask another question. How did Tesla do in Q4 2022? And notice all these are being returned based on our own document, own files, because the model does not have the knowledge after September 2021. So GAAP return is 3.7 billion. What about, let's check the debug. So second question, how did Tesla do in Q4 2022? Chat history is the first one that's been passed on. So just keep in mind all these are being passed on to the model. And now when the updated chat history has returned, you can see starting from the first question and then the first response and then the second question and second response. So this is how the conversation history works, and this is a workaround to give the model a bit of memories, a shorter memories, so you can ask follow-up questions. To another one. What did Biden say about Benji Jackson? Now this is a context from State of Union. I deliberately made a typo of the person's name. Here you go. Biden nominated Circuit Court of Appeal Judge Ketanji Brown Jackson to serve on the United States Supreme Court. Okay. Now let's see whether the model has some memories. What did Biden think about her? President Biden's party of when nominated, he described her as one of our nation's top legal minds. Okay, so in here, the model understands her means the judge. Okay, if I ask, what was the first question I asked you today? See whether it gets that. Now remember, we're using chain. The prompt within the chain is pre-built. We can modify that. So give me the answer. So let's ask one more question about Microsoft. It's a product offering. So what's Microsoft latest product offering? And what I'm demonstrating here now is our directory loader is able to scan all these documents and load it to our database to save it as a vector. The question didn't do it. What products are highlighted from its report. See whether you'll get what does that mean? It means the Microsoft. Here we go. Several products across different category, blah blah blah. Okay, so it's about a product offering. Can you list them as dot points with brief explanation? They talked about Microsoft 365 products, Windows, Microsoft Loop, security in their FY23 Q2. Okay, let's see what it gives us. It's taking a bit of time to think about these questions. Here you go. This is our bullet list. Right, it's quite comprehensive. Sure, here's a major product release and other highlights. So we had a Microsoft 365 product with a few highlights. We have Microsoft Security, Microsoft Teams, and Windows. Here you go. So that's it, my friends. Let's have a quick recap. Today we have learned how to use Python to build literally a ChatGPT to search over your own data. We learned chunking and embedding. We used Langchain chat with conversation chain to do the search, query the model, instead of using the typical GPT's prompt to do that. Finally, we put everything back together and built a web application using Gradio so you can chat with a bot on a web UI. Now, the final takeaway question for you and for myself is the token limit. I have not worked that out yet, whether the Langchain chain has a built-in mechanism that prevents or limit the token of the conversation variable. As you can see, the conversation variable will keep growing by adding previous chat's questions and answers and passing back to the model when a new question is answered. So at some point, this will hit the token limit that the model can accept. If the Langchain chain does not have the ability to reset or start reducing the tokens, we will get error. So if the Langchain can't do that, we need to build a few extra lines of code into our application, which will count the tokens of the updated chat history. And if it reaches our limit, the code needs to start deleting the very first chat conversations to keep the limit down. Now, let me know what you think and definitely reach out if you find out. I hope you have learned as much as I did and have a great day. Bye bye.